Hi there. Today we're going to be talking more about two-step equations and solving those there. Okay, we did a little bit just yesterday, and now we'll do a little bit more today. Just kind of a continuation of the same thing with a couple different types of examples here. All right, so in this case, they give you an example of one that looks a little bit like something you might use a distributed property for if you wanted to kind of put the 6 through there. It's like a 6 has been factored out of this whole equation, so you want to use this, get the 6 separated from the x plus 2 quantity right there. Now the 6, as we talked before, is joined together by multiplication to this other part. So to get the 6 away from this part in parentheses, I need to divide both sides by 6. That eliminates the 6 over here, so 42 divided by 6 is 7, leaving us with this equation, x plus 2 equals 7. So I'm keeping the parentheses there. I've removed the 6 by dividing both sides of the equation, my seesaw, by 6, leaving me there. Now I'm back to a one-step equation, subtract 2, and x equals 5. So you will have problems that look a little bit like this today for some of them, plus some regular two-step equations very similar to what you worked on in our last lesson. You also could have somewhere in your example here, you can see the number out in front of the parentheses could be a fraction. So in that case here, you're going to multiply both sides by the reciprocal. 5/4 multiplying this side, and 5/4 multiplying this side. So very much like what you did above here, where you divided by 6, here we're going to multiply by the reciprocal. One thing to keep in mind as you think about this here, let's look back real quickly at this one. If I had 6 times x plus 2 equals 42, we said, oh, divide by 6. But really, if you think about this, what I'm really doing is this is 6 over 1, and I'm multiplying by the reciprocal. Multiplying by the reciprocal. So while I can say I'm dividing both sides by 6, and it sounds like a different rule for each kind, it truly is the same thing. This reduces down to 1 still, leaving me with x plus 2, and this then becomes 42 times 1/6, which is really 42 over 6, and I'm back in the same spot I was before, back to 7. So while this might be more like multiplied by the reciprocal there, that's true, it's the same thing. So just keep that in mind, that when you have a number up in front, out here, that really can be looked at as 6 over 1, and then you multiply by the reciprocal just like you would down here. Alright, so that's the idea. So let's take a look at a couple examples. So again, I have a 7 out in front here. I'm going to divide both sides by 7. So that is eliminated there, and I end up with x plus 4 equals 49 divided by 7 is 7. Subtract 4, so that x equals 7 minus 4, 3 right there. Okay, that's that one there. Let's see, that's another 10, no big deal. We did one of those just there. It's the same as that one essentially, except working with a negative or an integer. Let's take a look here at this next one. We have 3/4 times that stuff there. So I'm going to multiply by the reciprocal, 4/3 times 4/3, this is over 1 in a sense. So reduce. So we have x minus 12 equals, well, look at here. I can reduce the diagonal. 1. 1 times 4 is 4, and I have that now. So now I have x minus 12 equals 4. Add 12 to both sides, my next step, so that x equals 12 plus 4 is 16. And again, I can check that out by plugging it into the equation to see if that holds true. Alright, let's look at one more. Let's do this one right here. So in this case, I'm going to multiply by both sides by the reciprocal. So it'll look something like this. So I have my original equation right here, and I'm multiplying both sides by the reciprocal of 7/9. So again, reduce. So on the left side, I have x plus 5. And over here, I can reduce on the diagonals, because that's 21 over 1. This is 1 7 in there, 3 7s in there. Don't reduce on the horizontal. 3 times 9 is 27. Let's subtract 5, so that x is equal to 22. So just a couple examples there. You'll have the same thing. Let me give you one more example right here. This is people that are actually watching the videos here, because you're going to have one like this in your homework, okay? You'll have one that looks like this. K minus 3 over 4 equals 10. And you might say, well, but that looks different. Well, again, how do you want to look at this? I would look at it like this. This is like having k minus 3 in a parentheses with a 1/4 in front. It's a way of rewriting that expression to look like something you're a little more familiar with. From that point, you'd multiply both sides by the reciprocal, which means this is eliminated, leaving with k minus 3 equals 10 times 4, which is 40. I'm going to add 3 to both sides, so that k equals 43. So if you see one that looks a little bit like this, all right, like that, you're going to have one. Think about this as being 1/4 times the quantity k minus 3, okay, or the difference k minus 3. So that's something to keep in mind. There's not an example of it here, but there is going to be a problem or two like this on the homework you do tonight. Okay, that's it for now. Give your homework a shot, and we'll see you back here in just a minute. All right, solving two-step equations. Here we go. I'm going to zoom in because I have to write itsy bitsy to do these problems. Loads of fun. I'm going to subtract 5, so I left with 3g equals 17 minus 5 is 12. Divide both sides by 3, divide by 3, so that g by itself is equal to 12 divided by 3, which is 4. Number 3, I have some more space off to the side, which is handy. I can rewrite it real quick. 13 equals 5m minus 2. Let's add 2 to both sides. So I have 15 over here equals 5m, because that becomes nothing. I'm going to divide both sides by 5 to get the m by itself. So m will equal 15 divided by 5, which is 3. Number 7, or 5, sorry, 7 was right there. We're going to add 5 to both sides, adding 5, adding 5. The signs are different, so I find the difference. 19 minus 5 is 14, and keep the greater absolute value, which is negative. So 7k is equal to negative 14. I'm going to divide both sides by 7, so that k is equal to 14 divided by 7 is 2, negative divided by positive is negative, so k equals negative 2. For number 10, well, let's first of all, let's subtract 7 from both. Number 10, I keep saying that, it's number 7, sorry. Let's subtract, sorry about that. Let's subtract 7 from both sides to have 3 equal to z over 2. Now z over 2 is actually nothing different than 3 equals 1/2 z, right? I'm just rewriting that fraction, the z over 2, as 1 over 2. Now I can multiply both sides by the reciprocal of 1 over 2, which is 2 over 1, or 2. So that 2 times 3 is 6, and that is equal to z. So don't get too hung up on those things, just view that a little differently, that z over 2 is the same as 1/2 z. Just getting real comfortable working with numbers. Number 9, we have 4 minus 3y equals 31. I'm going to subtract both sides by 4. So I have negative 3y equals 31 minus 4 is going to be 27. Now I'm going to divide both sides by negative 3. So that becomes a 1. And y equals 27 divided by 3 is 9. Positive divided by negative is a negative. So y equals negative 9. Number 11, another great one here. We're going to add 6, so that goes away. I still have negative 1/3 y equals 11 minus 6, because the signs are different, find the difference, is 5. Greater absolute value is negative, so we're good there. Now I'm going to multiply both sides by the reciprocal. The reciprocal is negative 3 over 1. Don't forget the negative sign. So times negative 3. I could write it as over 1, but it's not going to make a difference. So this part here is reduced to 1, leaving me with just the y. And that's going to be equal to negative 5 times negative 3, which is a positive 15. Number 13. Okay, first of all, I have like terms. Remember this from the other day? I have 5d, and I have, add the opposite, negative 8d. Because the terms are the same, I can combine those. Well, a negative 8 and a positive 5 is a negative 3, and I keep the d, equals 30. Divide both sides by negative 3, so that 30 divided by negative 3 is a negative 10, and that equals d. Number 15. I'm going to combine some terms here first of all. 9 and minus 7 is a 2m, and that's going to equal 11. 5 plus 2m. We subtract 5, so that 2m equals 11 minus 5, which is 6. We'll divide both sides by 2, and m equals 3. Number 17, we're going to combine our like terms. We have add the opposite, a negative 4 and a positive 1. Negative 4, positive 1 is a minus 3. So on this side I have a minus 3s. And I can also subtract 13 while I'm at it from over here. So I have 5 minus 3 is 2, 2 minus 1 is 1, and I'm there. So it's a little bit of doing, I would call it a shortcut, but it's not really. I just went ahead and did 2 steps in one space because I don't have a lot of space. Divide both sides by negative 3. 12 divided by 3 is what? It's 4. Positive divided by negative is negative, and that's going to equal s. Alright, number 19. Here we have an example where I'm going to multiply by the reciprocal, which is 1/3 times 1/3. Means that this goes away. I'm left with y plus 5 equals 21 divided by 3, which is 7. Subtract 5, so that y equals 7 minus 5 is 2. Number 21, going to multiply by the reciprocal, which is 1/6 times 1/6. Alright, so reduce. So on this side I have v plus 2 equals negative 48 divided by 6. 48 divided by 6 is 8. Negative divided by positive is a negative. So I have a negative 8 there. I'm going to write this over here. Negative 8 equals v plus 2. I'm going to subtract 2 from both sides. The signs are the same, so I find the sum and keep the sign the same. For negative 10, oh, I have a space there. For negative 10 equals v. Okay? And our last one, number 23, which was like one of the examples I started off with. Remember, this whole thing, I can think of it as being in parentheses, is divided by 7. So I'm going to multiply by 7, so reduce. I get z plus 5 equals 3 times 7 is 21, but it's negative because the signs are different. Subtract 5, signs are the same, find the sum, which is 26. Keep the sign the same, so negative 26 equals z. Alright, I'm going to stop right there for the day. That's all we're going to really do. That's it. Have a great day, and we'll see you next time.